Hello Polkadot, my name's Chris Wilson, and in this tutorial we'll learn how to create a generic Substrate compatible account and how to interact with the testnet faucet to get WND tokens for testing purposes. We can start by navigating to our Datahub, scrolling down and clicking on Start next to create a Polkadot account. We will be building on top of the Node.js application created in the previous tutorial, so make sure you've completed connecting to a Polkadot node using Datahub. There are currently a few different ways to create a new account on Polkadot or a testnet like Westend. Programmatically, with code, with the Polkadot API, which is covered in this tutorial, through a web browser by using the Polkadot app wallet, through a terminal by Subkey. We will be creating an account programmatically using the API. However, you might find it useful to explore the other options depending on your needs. So let's get started. We can create a new file named createaccount.js in our project directory. The top portion here appears more lengthy, but it hasn't really changed much from the previous tutorial. What's new are the helper functions from the Polkadot utility and Polkadot utility crypto portions of the API that will assist us in creating an account. Polkadot/util-crypto has functions to help us generate and validate a mnemonic seed phrase. Polkadot/util has functions that can help us prepare data for signing with our generated key pair. And keyring will help us manage sets of keys in a consistent environment and perform operations on these keys, such as signing and verification. FS will help us interact with our machine's file system. So let's copy and paste the following boilerplate into createaccount.js, and we'll go through it line by line below, adding the code to it to make it functional. So let's go ahead and we'll make the file createaccount.js, and then inside here we're gonna copy paste this code, and then we're gonna hit save. All right, so let's generate a mnemonic phrase. We will generate a random mnemonic phrase using Mnemonic generate. As a security precaution, validate the generated seed phrase using Mnemonic validate. Paste the following code below comment 1, generate a mnemonic. This is going to help us generate our mnemonic and to make sure that it is secure. So right here, go ahead and do this. And save it. Mnemonic. It's an adjective, assisting or intended to assist memory. Also, of or relating to a technique of improving the memory, of or relating to memory. When you see this word in code, it may be capitalized differently depending on the situation in which it is used. In all cases, it refers to the underlying concept of a memory aid, which is a series of words. Mnemonic generate can be given a word count of 12, 15, 18, 21, or 24 words. Without a parameter, it will default to 12 words. Those words are used to generate and derive keys. Read more about BIP39 by clicking the link here. Now we can create our account. We can do this by supplying the generated C phrase via keyring.add-form URI. Paste this snippet below comment number 2. So here we go. We're going to copy this code. Go ahead and put it in number 2. If it looks like that, don't worry. Just bring it back over here to the left. Everything's good. And then we're going to go ahead and save that. Come down here. The add from URI method extracts the phrase, path, and password from a SURI, Substrate URI, format for specifying secret keys. And you can see that here. The password may be omitted while soft key and hard key may be repeated and mixed. The secret can be a hex string, mnemonic phrase, or a string to be padded. It is important to note that we do not cover providing a pair password to secure encoded account data in this tutorial. Any accounts generated with this code should be treated as entirely insecure and are not intended for use in production environments. Here are examples of constructing a SURI. Don't bother copying these lines into the source file. They are only for an examination of the syntax for diversion paths. In the case of the substrate URI, we are supplying to add from URI. The password path is not to be confused with the pair password as implemented on the keyring. Using these means that an initial key derivation function is applied, so that even if the seed would leak, other accounts cannot be derived from that seed without the initial password. Unlike hard and soft diverations that can be mixed, only a single password should be specified per diveration. What are external accounts? That is when to set the isExternal meta key to true. An external account is one where the keys are not managed by keyring, for example, in Parity Signer or with a Ledger Nano. Now we can persist the account data. Place the following code below the comment line number 3, persist the account data. So we'll copy that, come back into our log, paste that under 3, save. This account data can now be persisted, another way of saying written to disk in JSON format, in a file which will be named with the first 8 characters of the address. We use the write file sync function from FS, which is one of the core modules of Node.js. Using JSON.stringify to format our file for readability is not strictly necessary. However, it is more difficult to read unless we perform this step. The code does not need to check for the existence of any account data files before writing, because it uses part of the unique address as a file name. Therefore, running create_account.js multiple times will never overwrite any existing JSON files. We will need to make a note of the mnemonic seed phrase of any account we intend to use, because the information is not written to the JSON file. In any case, this tool is for learning and illustration only and should not be used to manage keys for any actual project. Various address formats. The address format used in Substrate-based chains is SS58, which is a modification of base58 check from Bitcoin. Notably, the format contains an address type prefix that identifies the address as belonging to a specific network. For example, generic Substrate addresses start with 5. Polkadot addresses always start with the number 1. Kasama or testnet addresses always start with the capital letter like C, D, F, G, H, J. You can learn more about prefixes by clicking this link here. Signatures and verification. Finally, we will perform a verification check by signing a message with our newly created key pair. This allows us to be sure that our generated key pair will function for the purposes of signing messages, which is a fundamental topic when using any cryptographically secure blockchain. We will first convert our messages from a text string into an unsigned 8-bit array to perform the signing. The rationale for this being that we can .sign the message with a method from keypair, which is part of the keyring API we required at the beginning of our program. With this newly signed message, we can attempt to .verify it, passing in the original message. The signed message, thus supplying the public key of the signing account. In this way, we can verify messages without ever exposing the private key. The helper functions U8A TO hex and U8A to string are used here to format the data for readability. Write the following code under the comment line number 4, sign and verify a message. We can copy that, come in here. 4, sign and verify a message. Plop that in there. And as always, save. We can harness the power of string interpolation and the ternary operator here to easily construct some information. Dynamic output. This string interpolation express uses the question mark ternary operator to evaluate to in when the value of is valid is false. If is valid is true, nothing will be displayed. The two sign quotes with no space character between them are enclosing a non-existent string, hence no output. The colon character is indicating the branch. The code on the left side of the colon will be used when isValid evaluates to true, while the code on the right side of the colon will be used when isValid evaluates to false. And we can see that right here. Console log is telling us our outputs. Template literals are used extensively in many different kinds of software development. In a framework such as React, there can be different rules for template literals, but in JavaScript, the syntax should always be like that, where the expression can be a variable, a function, or even a complex combinations of both. The point to remember is that whenever we encounter string interpolations in JavaScript, it will always be inside backticks. The template literals are defined by a $sign and curled brackets. Building a sentence to be logged as output to the console in this way is a common technique for developers to keep track of the data flow inside of their programs. Logging information to the console is not necessarily going to help us display anything to a user on a website. However, it is fundamental to understand how to refer to the data we need. In code, a good bonus activity would be to play around with logging different information and constructing new strings, composed of various pieces of data. Now we can run the code. Now it's time to see our completed code in action and create our first Polkadot account. Now we can run node create_account.js. And remember, like I was saying, in order to run most of these Node.js files, you simply start with node and then name the file you want to execute. It's pretty cool. So let's do that now. Awesome. Look at that. So right here is our we have one available key pair. Our new key pair address is right here. We wrote account data to our JSON file. The mnemonic is right here too. So there's the 12 words we were talking about earlier. And here's our address. And then here's our signature key. So that is our account. We should see a similar output, and we do. Our account has been created, persisted, and is ready for action. Now that we have the ability to sign messages on Polkadot, we can perform other actions. Here's what the .json file made with the above mnemonic would look like. And we can go ahead and look at our own. So yeah, in here we can see our address, but it doesn't have the mnemonic. Oh yeah, and then there's the signed. Awesome. We must now add the mnemonic and the addresses to one of our generated accounts to the .env file in preparation for the next step, where we will be querying account information. For demonstration purposes, this address from the new key pair we generated would look like the examples above. However, we will want to insert the address we just generated instead of this example one, for the reasons that the example seed phrase above is public and therefore not secure. So we can go ahead and add this to our .env file. And you don't need the ticks. They're not necessary. You do want to, however, make sure you're not getting any extra spaces when you copy this over. All right. and then the address, which is right. Remember, it starts with a 5. And copy that. Oops. All right, and yay. All right, save. Okay. We're also going to want to keep our address on hand. We're going to need it for the next step. So completed and accurate .env file will look like this. And that's exactly what it looks like. All right. Now we can go back to our Datahub and click verify. All right, congratulations. We now have an account to interact with Polkadot on the West End testnet. Our account data is persisted in a .json file, which is named using the first 8 characters of the address in uppercase format. We also have learned how to verify the integrity of a signed message using helper utils from the Polkadot API. In the next tutorial, we'll be looking at different queries we can run against a Polkadot node to gather useful information. As always, if you had any difficulties following this tutorial or simply want to discuss Polkadot or Datahub tech, you can join our community forums or our Discord community in the link down below. And until next time, happy coding!